So let's talk about series circuits. Let's start off with a very simple circuit. I have a battery with a voltage VB and one resistor with the resistance R. Now if I know my potential, which is given by my battery, and the resistance, then using Ohm's law, I can solve for current. And so if I had the values, solving for current would just be my potential over my resistance. And since this is a circuit with only one resistor, this resistance is my equivalent resistance because there's nothing else to factor in. But let's say I have two resistors, resistor 1 and resistor 2. Now we know to combine these to one resistor, all I have to do is just straight up add them since they're in series. So this circuit can be rewritten as this, where I've still got my battery voltage and I've got my equivalent resistance. Now I know my equivalent resistance is just equal to R1 plus R2. And so if I use Ohm's law now, the potential drop of my battery, or potential given by my battery, is equal to the total current times my equivalent resistance. So that's equal to the total current times R1 plus R2. And once I find that current, I know current is constant in a series circuit. So that means the current here is the same as the current here. But we know that voltage is not constant, it's additive. So I have two different potential drops here, delta V1 and delta V2. Now using Ohm's law, I can write equations for those. Delta V1 is just I times R1, and delta V2 is just current times R2. And voltage being additive just means this. If I take and I start with my battery voltage and I add the drops across all my resistors, I should end up with 0. Now there's another way I can write this. I can put these values in for my potential drops. And I know, since that they're dropping, that both of these are minus. So I use Ohm's law to replace my potential drops with current times resistance. And I can use this equation to pretty much solve for anything in a series circuit. So let's do a quick example, a very easy one. I have a 9-volt battery and I have a 3 ohm resistor and a 6 ohm resistor in series. And so I can redraw this circuit by combining those two resistors. They're in series, so when I combine them, they just add straight up to get 9 ohms. So using Ohm's law, delta VB equals I times equivalent resistance. 9 equals I times 9, so I is simply 1 amp. So that means the current running through this whole circuit is 1 amp. Now, let's use the fact that voltage is additive. So 9 minus delta V across the 3 ohm minus delta V across the 6 ohm, or plus rather, I know that has to equal 0. So just like last time, I'm going to rewrite this is minus I times 3 minus I times 6, and that is equal to 0. And I know this is just 1 times 3. 1 times 3 minus 1 times 6 is equal to 0. So that's putting all the information in, and that tells me something I already know. 9 minus 9 equals 0. But if I'm looking for the individual potential drops, so what's the potential drop across the 3 ohm? That's just 1 times 3, or 3 volts. And then same thing for the 6, 1 times 6, 6 volts. And both of these are negative because they're dropping. And that's pretty much all you can solve for and all I can ask you for on a series circuit. So, things to remember with series circuit. Your current is constant. Your potential is additive. And to combine resistors, I just add them. Now, one more thing. Like I said in class, you better use Ohm's law. Because if you don't, you probably did something wrong. So I hope this helps, and see you in class.